My plan is to go over the homework that was due today. And then we'll go through as many examples as you guys need to. We can spend all day doing math if you want to. I don't care. But the plan is to go through the homework, go over everything you want to go over, and then when everybody's satisfied, there's no new lab today. It's just going to be catch up on any of the first two labs that you guys haven't done. I know some of you were still working the other day when we took off. So that's the plan anyway. If anybody needs extra help with anything else, just let me know. What chapter was it? 6? Cysteine? Past the due date. Whoops. What? All right, number 1. Sine wave voltage applied across a capacitor produces what? Yep. Alternating discharge and discharge current. Make sense or no? So like when you guys are going, I know I don't like lecture on this stuff before you do the homework. But if there's a part where you're reading through the chapter and you're doing the homework, like I would think that if you're reading through the chapter to do the homework, that you would understand how a capacitor works now, right? Can anybody explain how a capacitor works? It only allows current flow in one direction, right? It's gonna block. There's polarity there. So sine wave voltage applied across the capacitor produces alternating charge and discharge current. So there's going to be current going into the capacitor as it's charging, and then as it discharges, current goes the other way, right? That's what the alternating current means. Very common use of a capacitor is to block DC. That was, you had a question sort of like that in last week's homework, right? And that's the main function of a capacitor. Because of the inverse relation between X sub C, what does X sub C mean? Capacitive reactance. A capacitive reactance is a resistive value, but it only happens in alternating current circuits. And we'll get into more of that later. Because of the inverse relation between capacitive reactance and frequency or capacitance, the graph of X sub C versus C is what? Nonlinear. Capacitive current flows which one? Right. Because once it's charged, there ain't no current happening, right? So current flow alternates direction. So the charge switches direction, the voltage switches direction, and it discharges. True or false? Capacitive reactance is directly proportional to capacitance. Inversely proportional to capacitance. So as capacitance goes up, the reactance goes down. True or false? Capacitance is directly proportional to the frequency. Yeah. Let me ask you this. What's the formula for finding capacitive reactance? Do you remember it? Is it on your formula sheet? Right, it's false. So here's a capacitive circuit. This is what we're dealing with now. We have one capacitor in series with an alternating current voltage, and capacitive reactance causes the sine waves to shift. We'll see that in our labs, but if you have an AC circuit with just a resistor in there, the sine waves for current and voltage are in phase, which means that the peaks are the same, the valleys are the same, the alternations are the same in the same place. In a capacitive circuit, what happens is the current is actually before the voltage a little bit. Why do you think that is? Right, because you have that charge and discharge current happening. But what I wanted to see was this. Formula right here. This is capacitive reactance. X sub C equals 1 over 2 pi FC. So that question, right yonder, capacitive reactance is directly proportional to frequency. If something is inversely proportional, what does it mathematically look like? If Lewis is inversely proportional to Chris, how do we write it mathematically? Yeah, 1 over Chris. That's inversely proportional. If they were proportional, Lewis is directly proportional to Chris, which means as Lewis gets bigger, Chris gets bigger. In this case, if they were inversely proportional, as Lewis gets bigger, Chris gets smaller. Make sense? So in the formula, capacitive reactance equals 1 over 2 pi FC. Is capacitive reactance directly proportional to the frequency? Here's frequency. Or is it inversely proportional? Inversely. So as the capacitive reactance goes up, frequency goes down, or vice versa. So that would be false. Is capacitive reactance greater at higher frequencies? No, because it's inversely proportional, right? Oops. Here's the answer. So just give those to you next time you have to do the homework. Capacitive reactance is inversely proportional to capacitance. It's the same thing, same formula, right? Is that true or false? True. Look at the formula. Let's just leave this up here. X sub C equals 1 over 2 pi F C. There's capacitance. There's capacitive reactance. Combining capacitive reactances is opposite to the way capacitances are combined. If you have two capacitors in series, how do you find the values? Remember from last week? Right, two capacitors in series is opposite as resistors. You remember that? You're adding capacitances in series or parallel. It's opposite of if they were resistors. Well, think of it this way. Capacitive reactance is an ohmic value. It's a resistive value. Right? So the units for capacitive reactance is ohms, correct? We're going to do some examples and it's going to make all this stuff become more clear. But if this is farads and this is ohms, then yeah, they are opposite. So if we were adding two ohmic values, like a resistor, in series, these just add, right? Yeah. But if you had two capacitors in series, then we're doing that product over sum, right? So this would be C1 times C2 divided by C1 plus C2. Make sense? So combining capacitive reactances is opposite to the way capacitances are combined. For parallel reactances, the combined reactance is calculated by
the reciprocal formula.
Yeah, how do you know that?
Read in the book.
Good, leave me alone. What'd you say, Kyle? The key
I just
word
said
is
I
reactance.
read in the book.
You said bleh. The key word is reactances. This is an ohmic value. So you can kind of think of it in the same way as it's a resistor. So for parallel ohmic values, parallel resistances, we use the reciprocal formula, right? You can't just add them because they're in parallel. How much inductive reactance will there be if the capacitance is 10 microfarads and the frequency is 1400 hertz? Got to do a little math, eh? What's the formula for capacitive reactance? One divided by 2 times pi. What's the frequency? What's the frequency? What? 1400 hertz. Times what? What's the capacitance? 10 microfarads. So that'd be, we got to keep our units the same. So how many farads is that? 0.000. Zero one, right? I'm not a scientist. What? Can I? Yes. Oh yeah. This is how my brain works. If you want to do it scientific notation, it's totally fine. I know that's how John teaches you guys last 8 weeks. So that'd be 10 times 10 to the minus what, 6? All right, so then what does that give you? How do you do it on your calculator? Whoa. Well, you get your phone out because you can't use that on a quiz, but I don't have the calculator you guys have here. Or somebody tried to steal it from me. I'll get one of them and show you, but this should be the same sort of thing. One divided by, and for me, I'm doing parentheses, 2 times, where's pi? Where's the frickin' pi? I need some, oh, there it is. Pi times 1400 times 0.000001 parentheses equals 11.4. Let me look next door and see if I got one of your calculators I can use. That'd be more helpful. Nope, sure don't. I'm gonna have to borrow your calculator. What? You can write it down, and this is also being recorded, so anytime you need to go back and review this. Okay, so what are we doing? 1 divided by parentheses 2 times pi times 1400 times 10 e minus 6. Is that right? Then right parentheses equals. Okay.
You open the parentheses right after one divide, right?
Right. 1 divided by. I need to put that whole bottom thing in parentheses.
Okay.
So, yeah, so 1 divided by left parentheses 2 times pi times 1400 times 10 to the negative 6. Right parentheses equals. And if you're not in scientific notation, so if you're like me, you take this thing out of scientific. Engineering. Whoa! How'd you do that?
I don't know.
How do you put it into engineering?
You just go to second line and go to engineering.
Oh, there's engineering. All right. So engineering, scientific, whatever. If you're like me, I'm doing it this way. 1 divided by parentheses.
What's the difference? Just the 10
Exponents. The exponents.
Exponents?
Yeah. So that e to the minus 6, I don't do that. I type in 0.000001. My brain works better that way. I don't care how you do it. whatever you're most comfortable with. Okay, but I go 1 divided by parentheses 2 times pi times 1400 times 0.00001, right parentheses equals 11.4. Either way, you're going to get the same answer if you do it right.
Okay, thank you.
Boop. In a capacitive circuit, instantaneous voltage and current are 180 degrees out of phase. Is that true or false?
Like 90, yeah.
Mm-hmm. False. Does current flow through the dielectric of a capacitor?
No.
Correct. Current does not flow through the dielectric of a capacitor.
Oh,
Series or parallel capacitive reactances are combined the same way as capacitances. We already talked about that one. It is, but you have to keep, I know it's hard because capacitive reactance has the word capacitive in it. But remember, capacitance is a capacitor's ability to store charge. And this is a capacitor, and this is measured in farads. So this is a 47 microfarad capacitor. When you put it in a circuit, it has a resistive value, and resistance is measured in ohms. In DC, if I put this in a DC circuit, it ain't gonna do shit. It's not gonna do anything. It's gonna charge and it's just gonna sit there until you discharge it. In an alternating current circuit, it has a value. It has a resistive value, almost like a resistor. That resistive value, the way it affects that circuit is called capacitive reactance. So capacitance is its ability to store charge. Capacitive reactance is how it resists current flow in a circuit. Make sense? So if you could keep in your mind that capacitance is this different entity than the way it affects an alternating current circuit. So you have its ability to store charge measured in farads, and you have its resistive value in an AC circuit called capacitive reactance. Remember, this one is ohms. That's going to be key, because if you remember the capacitive reactance as an ohmic value, it'll make all these stupid little questions make more sense. That's just how it reacts in an AC circuit. Series are in the same way as capacitor. That's false. The base unit for capacitive reactance is, we just said it, capacitive reactance, ohms. That's key. It's a very key question. Remember the ohms. The current in an AC circuit with capacitive reactance alone is equal to Ohm's law, right? So think of it this way. Maybe we'll do this. Whoop, 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 whoop. The current for an AC circuit with X sub C alone is equal to. Tell me what Ohm's law is. What is? Something equals that. E equals I times R.
Sorry, I was going to volts and IR.
Yeah, E and V are the same thing. I was raised in this industry using E. On the front of your uglies book, does it say E or V? Same thing. You know what E stands for? Electromotive force. Voltage is the force of the charge in the circuit, the force. I ever give you the water? Did anybody give you the water pipe analogy? It's always helpful for me. Okay. I've got a water pump and I've got some pipes. And then I've got something resisting the current flow. I'm going to call it like a water mill. You know what a water mill is? Right? So I used to use water mills to like grind wheat into flour and stuff. Just haven't found a better example yet. Here's your water mill. Doing its thing, doing its work. Pumping the water. Through the circuit. So here's your water pipes and there's water going through here, right? So this is your pump. And this represents your voltage. So this is E. This is your force. A bigger pump will produce a bigger force on that circuit. It's going to force the water through those pipes harder. Okay? You have a certain resistance value from U to the earth, correct?
Yeah.
There's resistance of U. To get current to flow through your body, a certain voltage or a certain force has to exist. So between me and the earth, 120 volts going into my head is probably going to get a little bit of current flow to the ground, right? What if I put 480 up there? Current's going to be higher, right? That's where things become dangerous. Did you say shocking?
Yeah.
That was pun intended, right?
Yeah.
Where are you going? Take a shit? Oh, okay. Okay.
Quite fun
I'm just messing with you. Okay. What is the current? Current in this circuit is if you pick one place, one little place in this circuit of pipes, how much water is flowing through that point in a given amount of time. And the way they measurement is the coulomb per second. So coulomb is a shit ton of electrons, right? Or we could call it water molecules. So the current is how much water or how many coulombs per second are passing through that point in time. The more current you have, the more heat you have, right? And then your resistance to this circuit is the water mill. So it's doing its thing, it's rotating and doing some kind of work. But if I had a bigger water mill, I would have a bigger resistance. So this is current or amperage, and this is resistance or ohms. I can't remember now why we did this. Oh, because Ohm's law. E voltage equals current times resistance. The way to measure this is to say it takes 1 volt to push 1 amp through 1 ohm of resistance. So how many volts would it take to push 10 amps through 10 ohms of resistance? 10 volts. It would take a higher force. This being said, if this is voltage equals amperage times ohms, the current in an AC circuit with capacitive reactance alone is equal to what? Is capacitive reactance the same as ohms? Right, so in an AC circuit with capacitive reactance, the formula would be volts equals amperage times capacitive reactance. So capacitive reactance then, algebraically, if you solve it, equals voltage divided by current. Or E over I. So voltage divided by applied voltage divided by the ohms of what the, oh, the current. Okay, so that's for the current. I was getting confused. Okay, the current. So if we solve this for current, current would be the voltage divided by capacitive reactance. You understand that? Yeah. What we just came up with was E equals I times R is the same in a capacitive circuit would be E equals I times X sub C. So the current in this circuit would be I equals E over X sub C. So it would be the current equals the voltage divided by ohms of X sub C. Voltage. Current equals voltage divided by ohms of X sub C. Capacitive reactance completely applies to ohms law. Yeah, because it's a resistive value. Now that only works in an AC circuit. It doesn't work in a DC circuit. But in an AC circuit, a capacitor has a resistive value, an ohmic value, ohms, right? So we can apply Ohm's law there. So you say in DC they don't do anything. No, in DC, you're only applying current one way, right? This is DC and this is plus and this is minus. Yeah, current's going this way. In an AC circuit, it's going that way and then that way and then that way and then that way. 60 times a second is what you're getting out of the outlet, right? Yeah. Think of your water pipes again. Yeah. Your pump's only going one way. But in an AC circuit, the pump's going to push water this way, and then it's going to push water that way. And it's going to push water this way, and then it's going to push water that way, back and forth. The amount of times per second it does that is called the frequency. Right? So if I put a capacitor in there, let's say a capacitor in the water pipe circuit is like a valve. Capacitor is like a valve. It only works one direction. Okay? Or like a reed valve, you know what I'm saying? Like the reed lifts up and allows water to flow through, or whatever it is, fuel, whatever. So I'm the reed valve right here. I'm only going to let water flow in one direction. In a DC circuit, it's going to block it from going this way, right? In an AC circuit, it's going to go this way, and it's going to go that way. It's going to discharge, and it's going to go, maybe that valve is a bad example, but you know what I'm saying? It's different for an AC circuit because the current flows in two directions. Yeah, it makes the same current. Right. Mm-hmm. The symbol for capacitive reactance is X sub C. What is a capacitive reactance if a 120 volt, 60 hertz source is connected to a capacitor and the capacitive current is equal to 0.12 amps? What's your formula? It's asking for capacitive reactance. What's the formula for capacitive reactance?
1/2.
1/2 pi F C. So can we plug and play here? We have a frequency, but we don't have a capacitance. So this formula, I don't really think applies here. What is the capacitive reactance if we have 120 volts and 0.12 amps? Could we tell what that resistive value is? Maybe it's just Ohm's law.
Yeah.
So what does Ohm's law say resistance is? R equals E over V over I, E over I, yep. You can always look at your Uglies book. You can use your Uglies book on your quizzes and stuff, right? Everybody knows that. So E over I. What's the voltage? 120 divided by the current, 0.12. What's 120 divided by 0.12? A lot. Hmm? One thousand? No, we're calculating capacitive reactance. 120 divided by 0.12. Right. X sub C equals E over I. So in this example, we have 120 volts and we have 0.12 amps. So 120 divided by 0.12 equals, you have a calculator right in front of you, don't you? What's 120 divided by 0.12, 0.12? 1,000. Don't make this, don't overthink it. Make sense? I think in this question, they threw that 60 hertz in there to throw you off and make you try to overthink it, which I started to do. I'm like, oh, well, the formula is 1/2 pi FC. Well, we don't even need that because we have current, we have voltage, so we can use Ohm's law. What? What's good?
Think about AC, and we know that DC and AC, most of the time they are combined together.
What is the total capacitive reactance in a series circuit if 3 capacitors offered 150 ohms of reactance each? Yeah, that's another one you can overthink, right? 3 capacitors have 150 ohms of reactance each. Well, ohms is the key word, right? If you see ohms, you're saying, oh, that acts just like a resistor. Resistors in series, you just add them up. The confusing part is if it said, what would the total capacitance be of 3, 150 microfarad capacitors in a circuit? Then you're doing the reciprocal formula to find the total capacitances. Yeah. Yep. Right. Right. Whoa, 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 whoa. When a capacitor charges and discharges with a varying voltage applied, alternating current can flow. True that, homie? Which of the following is correct when working with AC capacitive circuits? Alternating current flows in a capacitive circuit with AC voltage applied. A smaller capacitance allows less current. Lower frequencies for the applied voltage will result in less current and more capacitive reactance. Or all of these answers are correct. D, final answer? That's right, all of them are right. Alternating current flows in a capacitive circuit with AC voltage applied.
The reason there's more capacity for love, less current, is because that's all quickly the they're more profit.
What was your question? The reason this one is true?
Yeah. It's they're smaller, so they're making faster.
What is a capacitance? What does capacitance mean? This thing. Capacitance is this thing's ability to do what? Store charge. So if it's like a battery, the big one, it can allow more current flow because it has a bigger ability to store a charge, right? It's a smaller one, low, then it allows less current because it's just going to charge up and stop, right? Lower frequencies for the applied voltage result in less current and more capacitive reactance. Well, the key words for that one for me are lower frequencies. So this goes down. They're inversely proportional. So that means this must go up. More X sub C. So that one's true too. So all of those answers are correct. Which of the following is correct? Capacitive reactance is inversely proportional to capacitance. That's true, right? Boop. Same thing. Capacitive reactance right here. Inversely proportional to capacitance. Yep. So you need to read the rest of them. X sub C equals 1 over 2 pi FC. Cool. This formula? It's for finding capacitive reactance. It's the same as this one that I just put up here, right? Oops. X sub C equals 1 over 2 pi FC. All right, well, that was a lot. I need to look in the quiz, there will probably be some circuit solving with these. Okay, that's not till next chapter. Okay, so that's enough. That's enough to throw at you right now so we can get through chapter 16 quiz on that'll be Tuesday. Right? Okay. Do you guys have any questions on any of this stuff? Anything not making sense yet? We'll do this as long as you guys want to get it through your heads. If anything else comes back up, if you're looking at it over the weekend, if you're watching the video of this over the weekend, then we'll go back over things Tuesday if you want to before we take a quiz. Otherwise, we'll plan on taking the quiz Tuesday, and then we'll move on to the next chapter. That's when we start to do a bunch of math. And I like math. Math guy. It's like solving the whole circuit. So you're using this stuff to solve everything in the circuit. Okay.